Hey, so this is macros for a more productive Rust. Just a little bit about me before we get started. My name is Jam. I use he, him pronouns. Professionally, I do security research. However, in my free time, I mostly focus on modding, general open source stuff. So, macros. Here's the simplest macro. It's composed of only a few parts. You have the declaration, which just sets what the name of the macro is. You have the pattern, which essentially handles parsing the input to the macro. So you might have different types of syntax fragments. So you might have expressions, you might have names of types, you might have identifiers. You can basically pass arbitrary Rust into it, and you can set what different things you want to match against. And so then you have the expansion, which the expansion is what the macro becomes after you call it. So as the name implies, it is what it expands into. And then you also have, here's an example of calling the macro. So in this case, just passing in a simple 3, which is a valid expression. And if we want to see what it looks like when this expands, we just basically take the expansion and we template in the variable that we're passing in. So in this case, it's just num, which is going to be prefixed by $. And so then it expands to this. If you want to expand things on your own, there's two really great resources for it. There's cargo expand, which is a cargo subcommand made by David Tolnay, which just allows you to see, okay, what happens when my macro expands? What does it expand into? And you also have the ability to, under the Rust playground, at the bottom of the tools section, you have the ability to expand your macros. And so highly recommend going on Rust playground in order to play around with that. So another feature of macros is that you can have it match against something multiple times. So kind of like regex, where you have star plus and question mark to control the amount of times you match against something. It's exactly the same here in Rust. You define a capture group and then you say, okay, how many times do I want this to repeat? So you use like star if you want 0 or more. You have question mark if you want it to be once or no times. And then the last big feature of macro rules macros is that you can have multiple different patterns that you're matching against, and the different patterns can have different expansions, and so that allows you to essentially encode parsing logic in order to figure out how you actually want to handle your expansion. So in this case, it's just a simple macro which expands differently based off of whether or not you pass a 2 or a 3 into it. Simple enough. So when we put those all together, we can do a lot cooler things with macro rules macros. So for example, we have this trait called asBytes. It's a simple trait. All it does is takes whatever structure that implements asBytes, and then it converts it into a vector of bytes. So for example, if we want to implement it for U16, we might use the associated functions for converting U16s into bytes. Simple enough. But the thing is that if you have to type this in for every different integer type, it's going to be a lot of repetitive code, and it's not going to be easy to manage it after you've written it. And it's going to be harder to, not necessarily harder to read, but it's just going to be a lot to read. And anytime you have to go in and make a change, you're going to have to change all of them. But we can remove that if we use repetition from before in order to implement the trait for all of the integer types at once. And so the way we can do that is first we just wrap our example implementation in a macro. We set it to repeat. We then make it so that we have our pattern be matching against repeated comma-separated type names, and then we replace every instance of U16 with our type name. And so that allows it says, okay, generate this code in multiple repetitions of it for whatever given types we pass in. And so then if we call it with all of the types, it'll generate implementations for all of those types. And then we only have one implementation that we have to maintain, and it's the templated one. And so some intermediate techniques for macro rules macros is you can use internal rules, which basically in this example we have two macros. We have macro 1 and we have macro 2. And macro 1 calls onto macro 2, and that might be necessary because, like I said earlier, the only way to really encode parsing logic is if you have multiple patterns or rules that you are matching against in order to encode that logic. And so if we have to have multiple steps of parsing logic, then we end up having to have essentially multiple macros to handle each layer of logic. And so in this case, this actually causes a problem, because if we import macro 1 into scope but not macro 2, then macro 1 tries to use macro 2 after it expands, but it's not in scope. So how do we fix this? So basically what we're going to do is we're going to collapse the two into a single macro. And so the way we do that is with internal rules. And internal rules are basically, you have a pattern that starts with @ which that's just by convention, but it's highly recommended because @ isn't really used very often in Rust syntax, so it's not likely to cause any collisions with the things you're actually trying to match against. And so in this case, since our previous macro was called macro 2, we instead have a rule that matches against @ macro 2. And so basically what that allows us to do is we can have macro 1 recursively call itself, but then passing @ macro 2 at the start of the inputs to macro 1 in order to call the internal rule. And so another important technique is called a TT muncher. And so TT stands for token tree. And basically what's happening here is that everything in Rust is going to be split up into tokens basically in a tree format, because if you have like brackets, everything inside of the brackets is going to be a child of the bracket tokens in your token tree. And so if you match against repeated token trees, then you match against everything that gets passed into the macro. And so if you match against something and then the rest of the token trees, then you can essentially say, okay, I'm only matching against the first token, and then I can pass the rest of those token trees back into the macro. And so I can handle parsing one set of tokens at a time. So in this example, we have matching against either up or down, and each time it's followed by the rest of the token trees. And so if we actually look at what happens when we try to handle that, is we have up, up, down, down, and then it matches against that first up for the first branch of it, and then it captures the up, down, down as the rest of the token trees, and then it passes that back in to the macro. So then it's just another call of up, down, down. And then those recursive calls allow us to handle it one at a time, going down, down, and then down. And then we hit our base case, which is just when nothing gets passed in, we then just do nothing. And so after that, it expands into nothing. And then we have all of our code, and we've been able to handle it one set of tokens at a time. So we can have multiple repeating tokens, but each one has parsing logic for handling, okay, I match against up or I match against down. And so one really useful crate for when you're writing macro rules macros is called paste. And so one of the limitations of macro rules macros is that you can't create new identifiers, but what paste allows you to do to circumvent that is it allows you to concatenate different identifiers in order to create a new identifier. So in this example, it has the 4 identifiers Q, R, S, and T, and it concatenates all of those to form QRST. And so absolutely great crate. If you wanted to find this crate or other crates like it, David Tolnay, the person who actually made paste, actually has a site that allows you to look at a lot of useful stuff related to macros. It's actually his GitHub. So proc macros, the other type of macro, different from macro rules. So proc macros, the general idea is that you're writing another Rust program, which then takes in a series of tokens, and then it returns a series of tokens. And so, for example, we have function-like macros, which are basically the same thing as macro rules macros, except they're a little bit more powerful because they're proc macros. And you can have arbitrary Rust logic for determining how you modify your stream of tokens. So in this example, it's a JSON macro from Rocket, and it allows you to essentially just straight up write JSON within your code and even use Rust expressions as values or keys within your JSON. And that's great for like if you're writing a web server and you want a quick ergonomic way to build a JSON response, a wonderful way to do it. And so then we also have attribute macros. So attributes are just those little things that go before functions or static variables or anything like that. And so what this allows us to do is essentially associate data or some action or something with the function or static or whatever itself. And so in this example from Rocket, it's the get attribute macro. And so what that allows you to do is you can mark a function as a HTTP GET handler. And so in the example, we have the path /hello/name/age. And basically what it does is it takes whatever URL path you're going to. So like it might be /hello/jam/whatever. And then it handles the name and age and actually passes it into those functions. And so that allows you to remove a lot of boilerplate that would otherwise be required for either handling the different routes or actually pulling the information out of the routes, and it makes it a little bit more robust as you don't actually have to have the error-prone nature of trying to pull that information out yourself. And so lastly, we have derive macros, and essentially if you're familiar with Rust, you're probably familiar with the concept of deriving things like clone or debug or copy. And so what derive macros allow you to do is it allows you to have your own derive handler for implementing a trait automatically. And so here's an example from Serday in which you can, and what Serday allows you to do is allows you to derive serialize and deserialize for arbitrary structs or enums, and then you can actually serialize it or deserialize it to and from whatever format supports Serday. So for example, Serday JSON is a crate for converting to and from JSON strings, and it's absolutely great. You should definitely check it out. And so proc macros, if you want to create one yourself, all you have to do is create a new library, throw proc macro equals true in your toml, and then you just have to make a function which takes in a token stream and outputs a token stream. So here's an example of how we can make a proc macro. And so what this does is this is a attribute macro, which you put it at the top of a function. And what it'll do is it'll insert a print statement at the beginning of the function so that it prints out, okay, I'm entering this function, which allows you to trace things. So basically, the way this macro works is first up, we have a line that uses syn parse macro input. And so what syn is, SYN, is it allows you to parse arbitrary Rust source from tokens. So like in this situation, it's parsing the input to our proc macro as a function. And it also handles the error handling for you. So it'll give you a pretty error if someone tries to pass in something other than a function. And so then we take the name of the function and convert it to a string. And so here's syn parse quote. And so what that allows you to do is quote is a crate which allows you to essentially pseudo quote your code and convert it to tokens. So in this situation, we have this macro parse quote, and essentially we can just write whatever code we want in there, kind of like when we're doing macro rules macros, and we can template different tokens into it. So in this case, I take the function name and I template it into my code. And then in this case, since it's parse quote instead of just quote, it then parses it into a statement in this situation, and then we insert that statement at the beginning of our function block. And then we use quote to convert the function back into tokens and return it. And that's all it takes. So let's see some things that show how powerful proc macros are. So here's an example called treeflection. And if you're at all familiar with C# or Java or other object-oriented languages that have the feature of reflection, essentially what it allows you to do is it allows you to, at runtime, take a look at what are the actual names of fields within like a structure or a class or whatever, and what's the layout of them. And that essentially allows you to just kind of have programming related to the layout of your struct. And so in game dev, you might use that to allow your developer console to modify arbitrary structures at runtime. And that's a very useful tool. And so what derive macros in this situation allow you to do is you can actually kind of replicate reflection, but instead of handling it all at runtime and incurring those costs, you can instead have it at compile time, because you can derive it for each of your structures that you're using. And first off, you're not paying for it for any of the structures that you don't want accessible, but also you can generate efficient code for each different type, and that allows you to essentially have it so you have compile time reflection where you're generating unique functions for each type that handle it as efficiently as possible for that specific type. And so here's another example. This is a macro I wrote called binRead. I definitely recommend you check it out if you are doing any binary parsing. But essentially the idea of it is, instead of writing a bunch of code for handling your parsing logic, instead use your struct declaration and use the ordering of your field and some metadata in attributes in order to actually encode the parsing logic, so that you don't actually have to write your parsing code. You have your parsing code generated for you. And so that allows you to have kind of declarative programming for your parsing. And I think that was a pretty successful experiment. But one cool thing you can kind of learn from this is basically when you're implementing a derive macro, what you want to do is you want to offload as much of the actual like code out of the proc macro itself and into, for example, like a trait. So in this case, I have like binRead, the trait in question, implemented for all of the like integer types and all the other primitives, and then some more helper types. And then my derive macro, all it does is it generates some code that A, uses the attributes involved with it in order to generate some code, but also B, to handle just kind of recursively calling the trait on the types used in the struct. And that's basically how all derive macros are going to work. And so here's one of the really coolest examples of how you can use function-like macros. And for function-like proc macros, since you can just write arbitrary tokens in there because it's inside of a separator and therefore doesn't actually have to be valid Rust, like an attribute macro, if you attach it to a function, it still has to be a valid function, but within it, you can kind of, it has to like parse properly. But with function-like macros, since all of your tokens are like in parentheses, you can essentially have arbitrary tokens and you can encode your own syntax. So like maybe something that's domain specific, like on the top left, I'm encoding some information about, okay, this is just a arbitrary language that allows you to encode moveset information for a game. So like, okay, wait 16 frames and then create a hitbox and then do this and that. But an even cooler example of using that is this crate called inline Python. And so you might think, inline Python, that doesn't make any sense. Rust has like, it doesn't care about white space. It's completely ignores it. It just parses the tokens between the white space. So how can you encode Python? Like, Python is dependent on the white space. You have to have your tabbing correct and everything. But the thing is what inline Python does is it looks at your tokens. So for example, in the bottom right, we have like the 4, and then we have the print on the next line. And we can look at the line numbers of those tokens, and we can look at the column numbers of those tokens, and we can figure out, okay, there is a tabbing here, and we can recreate the white space from the positions of the tokens. And this allows you to essentially write arbitrary inline languages for your specific domain. So if you want to write Python that pulls Rust variables, you can use inline Python, or you can write your own. And that's insanely powerful. And so here's an example of an attribute macro, also one I wrote. It's called Skyline Hook. And essentially what it does is it allows you to replace a function in another binary with your Rust function. So in this case, you just provide it like a program counter, and then you provide it your function, and then it allows you to replace that by doing a bunch of nonsense in the background to actually handle like the code patching and everything like that. And it even allows you to call the original function in case you actually just want to like modify some of the input variables and then defer to the original. And one great example of how someone used that is somebody made a Pokemon randomizer. And so it really just takes one like 50-line function where it just randomizes some values in some function it's overriding. And that's all it takes. And the attribute macro actually handles all of the inserting your code patching and everything like that. But can we take macros even further? So in an earlier talk, Esteban started talking a lot about Rust++, and it got me thinking, you know, like Rust, great language, I love it, it's my favorite language, but like, it still needs a lot of features. Like, if you think about it, like, it can't interop with C++ at all, like, what's up with that? And like, also I don't have the ability to do inheritance, like, is Rust not even an object-oriented programming language? Like, I don't understand. So like, the conclusion I came to is Rust must be a bad language. Like, you know, a good language like C++ has these features. Kidding, obviously. But still, this got me thinking about like, oh, you know, what if we actually introduce inheritance and C++ interoperability with a macro? And so I made this crate called CPP inherit, and what it allows you to do is it allows you to inherit Rust types from C++ types and even like override virtual functions. And in the background, it, you know, calls out to GCC and it says, compile this header file and give me the dwarf information for it and show me what the vtable layout is so that I can recreate it within Rust. And it generates a bunch of code in the background for handling that all for you, so that you can inherit from C++ classes using Rust structs. And so that's all I got. Thank you for watching. It was a great time.